All right, good morning, everybody, and welcome to another live stream. Pretty excited about this one today because this one we are really kicking off our Summer of Rag series in earnest. In fact, I would call this the fundamental stream. And what I mean by the fundamental stream is I mean that today is going to be a very, very high level overview of what retrieval augmented generation is. We will be coding it all. We're going to be sharing the concepts, but this is going to be largely a stream to help ground the intuition for the future stream. So we're going to take an extremely basic approach to retrieval augmented generation today, and then in future streams we'll iterate on what we've done today to make things more advanced and more performant for your own use cases. So I am sliding into this one hot. Like I just finished some like the last minute touches of work here, and honestly that was because I woke up this morning and played Elden Ring a bunch because I wanted the DLC's coming out. It is coming out in a couple days, and I did not realize that there's like a prerequisite, like you got to be so far in the game in order to unlock the DLC. So I got busy playing that, and so I literally just put the final touches on what we're going to cover today a few minutes ago. And if you're wondering why I'm also just a little bit disheveled, it's because I plant so our neighborhood has a don't do loud things like mowing before 9 a.m. sort of thing. So which is fine. So I'll just we'll do the stream, and then if you live around me, you'll see me mowing my lawn right afterward. All right. So anyway, enough waffling around. So let's talk about what retrieval augmented generation is with a high level concept. So just FYI, this is Perplexity, but I turned it on into writing mode. So basically, we're using this like a typical LLM. Pretend this is just like the typical Chat GPT. So one of the most important things that people are really interested in with retrieval augmented generation, and particularly in the business and the enterprise context, is being able to use your own information to augment the responses from the large language model. And so what I mean by that is so in the previous stream, what we had done is we generated a toy data set that we're going to continue to use here, and that toy data set consists of a fake knowledge item. So every major company out there has a knowledge management system of some sort, and what the knowledge management system is there for is to if let's say you're all these major companies have some sort of IT help desk. Everybody's working on computers these days. So, if an employee needs to call in and figure out how do I change my password or something, then the person on the other end of the line, the call center employee, if they don't know necessarily how to do that, then they can go into this knowledge management system and reference that knowledge. Now, of course, some of those more basic things the employee is going to memorize over time, but you can imagine that the larger the company is, the more opportunity is that you have to learn a bunch of knowledge, and you can't really expect a single employee to memorize all that, especially if they're brand new. So there are three ways, and actually, this is the other thing I meant to bring up, but I forgot to bring it up. I'm not going to touch on this too terribly much here because I'm just going to point you to my blog post. So there are three high level ways that your company can think about incorporating your information with generative AI. And again, this post here goes much more deeply in on this, but you can see here that here are the three. So the first one's building your own model from scratch. The second one is fine tuning, and then the third one is retrieval augmented generation. Now all three have their pros and cons. I would say that, in my opinion, you would want to and again, I'm not going to go through this whole blog post here, but you can see why I would say start with a RAG, and the reason for that is it's the easiest to get up and going, and it's the most cost effective. It's most cost effective because building your own models from scratch, that's really expensive. Fine tuning can also be really expensive if not done in an appropriate manner. So, but retrieval augmented generation, to be clear, can be very performant if done correctly. And we'll talk more about some of the pitfalls of retrieval augmented generation if not done correctly as we continue along, and even as we continue along into future iterations of the series. But yeah, so if you want to learn more about, the pros and cons of each of these approaches, go and check out this blog post here, but I'm not going to touch on that too much more. So what retrieval augmented generation is, though, is it's basically just adding extra context as like a query input, if you will. So like, let's say I'm going to ask this question here. What wait, let me think about it, how I want to phrase this for a second. Okay, I'm going to say, please fill in the following blank. In the morning, I like to drink blank. Okay, which is very apt because we are in a morning today and I am drinking what I like to drink. In the morning, I like to drink coffee. Okay, so that is the answer that we got back. So this is, by the way, it's using GPT-4o behind the scenes. It answered this way with coffee, but how did it know how to answer this way? And without going too deeply into how large language models work and everything, it's basically this idea of like, so if you think about when the model is trained at a point in time, it's trained on all this data that is looked at across the entire internet. And it's basically looking for statistical probabilities of whatever the next word should be. So because we don't have any additional context aside from what we've given it in this context of in the morning, I like to drink blank, it filled it in with the word coffee. And it filled it in with the word coffee because it probably looked at, the model probably noticed the words morning and drink, and then probably gave it like a best guess as like it's somewhere in the neighborhood of a breakfast beverage. And at least we Americans, when we think about breakfast beverages, is coffee. Now, if you live over in some other part of the world, you might think tea automatically, or maybe even water or some other drink. But you can see here, this is how it answered. And it answered, you can notice, very confidently. Like it did confidently in the sense that it did not waffle on its response. It didn't say, I'm not sure, you didn't give me enough information. It just says, I like to drink coffee. So technically speaking, you could call this a hallucination, because it doesn't know what I like to drink because I did not give it the context of what I like to drink. So let's go back and update this now. So let's say for context, I like to drink Starbucks iced coffee every morning. So there's the context, just plain text context. Now let's ask the exact same thing that we asked before. Please fill in the following blank. In the morning, I like to drink blank. All right, so now let's see how it fills this out. And so you can see now that we've given it the context just as plain text. It does now actually give a more precise answer. In the morning, I like to drink Starbucks iced coffee. And again, that's because we gave it the context. So you can imagine now that when it comes to retrieval augmented generations for things like knowledge items or whatnot, like, so if a user goes in and asks like a question, how do I reset my password? Then what we're going to do is we're going to look for the specific knowledge item that is correlated to that question, so that way we know how to answer that question the best. Because like if we were to just ask straight up, in fact, let's just go ahead and just for practice see what happens here. In the morning. Wait, what was I gonna ask? Oh my gosh. Oh yeah, how do I reset my password? Okay, let's see what happens here. Yeah, so now so by default, it's not even sure what sort of password I'm trying to reset. So you can see here that GPT-4o is like, well, I don't even know what you're really asking for. Are you asking to reset your Gmail, or you're asking it for your Twitter, blah blah blah. And so in your particular company's context, you probably have a knowledge item out there that says, okay, follow steps 1, 2, 3, 4, 5, very specific steps to your company systems on how you reset your password or anything like that. And so that's what we're going to be demonstrating in this stream, is how do you actually build a RAG pipeline like that, so you can actually use the knowledge that you already have from your company, or use any sort of information that you want to use, and augment the output from the large language model to give a more precise answer back. All right, so I'm trying to think. just trying to think through the flow of the stream here right now and how I want to proceed forward. Oh yeah. So let's talk a little bit about this picture here. All right, so what this I assembled this picture last week. So this is a high level overview of how like the core paradigm of how retrieval augmented generation works. So you have basically like two halves of retrieval augmented generation. In the first half, you have your storage and indexing. And so what your storage and indexing is doing is it's taking your corpus of knowledge or your corpus of documents, whatever knowledge you are wanting to augment later on, and it is basically storing it so that we can properly make use of it later on. And so let's go ahead. Well, yeah, so let's pause there for a second and let's cover over here what this is doing at a high level, and then we'll go into each of these boxes more at a lower level. So that is storage / indexing. And so then on the right side, so this is all done like as a pre-prep kind of step. Like this is going to be something that is going to be done like at an initial load. Now, granted, like if you have a knowledge management system, your knowledge is probably being updated constantly, so you probably are going to have Delta updates on a daily basis or a weekly basis, whatever, to ensure that your knowledge is up to date in these things. But then when it comes to the actual like time when the user wants to make use of that knowledge, that's where like all steps 5 through 8 here are noted. And it probably is not fair that the numbering system that I put here, because these really are kind of two disparate processes. But I thought the way that I lined it out here was, helpful to in at least in a contextual way to think about these things. So so basically on this other half here, this is where the user is asking the question, and then we're getting the context from the AI there appropriately. So let's go back on over to the storage side of things here, and let's delve into each of these boxes more deeply. So first things first is that's a little bit pixelated, isn't it? Well, all right. Well, I guess we're just gonna have to make do. I don't like. That is disgusting, that pixelation. So anyway, so the first step here, corpus of documents, wherever your documents are located, need to be extracted and undergo some form of text pre-processing. Now, in this particular stream, this is going to be a rather simple demonstration, but this is probably the step that I advise people most often of, like, if you are working within your company and your company's still kind of working out their AI processes and whatnot, and you're still kind of waiting to get approval to use some sort of large language model or whatever, this step here can be the most time consuming step by far. And as you can tell, it's not even touching the large language model. So what do I mean by that? So unfortunately, like a lot of big companies out there, their knowledge is not necessarily organized in the best manner, meaning that like you might have a few knowledge items over here, and you might have a few knowledge items over here, or whatever. And they're just all over the place. And unfortunately, the one misconception that I want to address here is that and I think I've addressed this in previous streams too, is that the large language model has no means of being able to like the analogy I always say is like, some people like to think it's kind of like a spider bot where you just drop it in and it will comb throughout your system and figure things out. Unfortunately, that's not how that works. Like the way this works is you have to get all your knowledge into a single place here before we can even go through and do these next sort of steps. So if you are thinking, if you and your company are wanting to make use of some sort of retrieval augmented generation process, my first piece of advice before you do anything is start figuring out a plan to get all your knowledge in a centralized location or a single place where you can start doing these processing from. So this is, like I said, this is going to be rather basic for this stream, and we'll cover some more different forms of text pre-processing and loads in future streams. But so that's step 1. Step 2 here is, so like, all right, so we have each of like our documents here. You can see that we got multiple documents represented here. And so step 2 is we take this document and then we break it down into an arbitrary number of chunks. Now, I guess it's not arbitrary, maybe is not the right word here. It's because we'll talk about like different ways of chunking in the future. But basically this is the idea. Like, so imagine that, like the example that I always use is, because we're trying to find the most similar. Later on we're going to do a contextual match to find the most similar information to the user query. And so, like, let's say I'm wanting to do this amongst the Constitutional Bill of Rights. So if you're not familiar with the Constitutional Bill of Rights, there are 10 amendments in the Bill of Rights, so 10 different things that it's talking about. So like the First Amendment's like freedom of speech. Second Amendment is right to bear arms, and then and so on and so forth. So the problem with that is, so like let's say I ask a question like, what does the First Amendment talk about? So when we are trying to retrieve that information from here, the problem is if it's all in one single document, like then you're just getting back the one document, and then like you're getting a bunch of irrelevant information alongside that. So like if we haven't chunked down the Bill of Rights at all, we're getting the whole thing back. Whereas so instead what we want to do is we want to have some sort of chunking pattern here. So maybe we chunk it down by different amendments instead. So instead of like storing the Constitutional Bill of Rights as a single document, we chunk it down by amendment. And then, but that's not the only way to do chunking. Like there are many ways to do different chunking, and it's like the one that we're going to do in the stream today is extremely basic. It's just doing a token count. It's just finding the number of tokens and then cutting it off there. So there, again, we'll cover in future streams other different sort of chunking patterns. All right, so let's move on to step 3 here. So step 3 here, this is where things start to get a little bit interesting. So this is where we take each of the document chunks here, and then we pass it through a vector embedding algorithm to produce these vector embeddings. And so I've represented them here. I've got 3 different examples. Now you can see in my 3 examples here that we just have 2 numbers representing each document chunk. In reality, each of these vector embeddings is something like, can be upwards of like 400 float values long, and it's usually something that's much longer than like a 0.3. It's like usually like 0.35752, whatever, yeah, so on and so forth. And the reason we'll delve into this more in a future stream. I don't want to cover this too terribly much here, but the reason that this is valued is because then when so like imagine that each of these chunks are probably going to be, especially in the Bill of Rights context, they're probably going to be a different length in this. So in the sense that like maybe the text around the First Amendment is longer than the text around the Second Amendment. So it's hard to do an apples and oranges comparison when you have these lengths that are of different length. That was a terrible explanation. It's hard to do a comparison if you got one thing that is really long and then another thing that's really short. So what this vector embedding algorithm is doing is it's transforming the documents, no matter how long the document is. It could be 2 words, it could be 1,000 words, into this vector representation that is always this fixed vector length. That is always going to be 400 values long or whatever. And the value of that is, mathematically speaking, then we can do what is called like a similarity search, because I'm getting ahead of myself a little bit, but just for now, because we'll cover that here in a second, just for now, just know that in this step here, we are taking each of our chunks and then we are embedding them into these vector embeddings. And then so step 4 here, rather simple, is we're just taking these vector embeddings and then we're sticking them into some sort of vector store, like a vector database, along with metadata and whatnot. And that basically covers the first half here. All right, so let's move into, so that gets all of our documents into the vector store itself. So let's move on over to the side of the retrieval and generation part here then. All right. So so the user is going to ask a question. So I've represented it here with this like little question bubble here. And so we are taking the exact same vector embedding algorithm that we used over here and embedding our user's question here as a numerical vector. And the reason that we do this here then is then when we move into this step over here, so you can see here we have our vector embedding of 1.2 or 1.3, 2.5. So you'll notice I intentionally tried to make the numbers look a little bit similar. So you can see that 1.3 and 2.5 is very similar to the 1.2 comma 2.6 here. And basically, like, and again, we will talk about this more in a future stream, but basically it is doing this mathematical calculation, usually a cosine similarity calculation, to determine, okay, yeah, this document here, or the one that our query here is the most similar to this contextual chunk over here. And so then we can use, so then we take this contextual chunk, this 1.2, 2.6 chunk, and then what we do is we combine it with the user query as that context thing. So that coming back again to my simple example here, the Starbucks example here. So this is basically this context here. Like, so you can imagine that, oops, my apologies. This chunk here would be like the context here that we provided it. And then like the actual user query then is like the please fill in the blank sort of thing here. And that is basically representing this final step here. We take our user's query in plain text plus the plain text of the contextual document, and we pass it into the large language model to get a response back. So that is the core principle of how retrieval augmented generation works. If you understand how this works, then you're good. Like you're good for the future streams. But let's ground this even further in the form of code now. All right, so what I'm gonna do here is I'm actually just gonna go to Kaggle, and I'm gonna, so by the way, I do have a notebook out here that I just made it public a little bit ago. We're basically gonna be covering this notebook here today, but I'm gonna start it from scratch. So just FYI, if you want a cleaner version of the notebook that's got like nice markdown cells describing what we'll be doing, like then we could do that. But let's go ahead and start anew with a fresh notebook. Okay, and so, all right, I'm gonna get rid of this because I don't need this. All right, so first things first, I need to add our data set. So this is the data set that we used from, or I'm sorry, the data set that we generated in the previous stream. And we'll demonstrate it here in a little bit. And then I also need to do a little bit of admin things here. So I need to get my API keys because we're going to be using the OpenAI API here. And then I also need to do a couple pip installs as well. All right, so I'm going to add pip install. Here, where's my work? Where's my work? Your work. All right, load API keys, pip install. All right, now, all right. So I'm gonna do from pip install import perform pip install from load API keys import load API keys. Now the one thing I need to do is I need to actually load in my API keys, or I need to, I'm sorry, not load them in, but attach them to this notebook. All right. And just for context, while this is kind of loading up, I've really gotten into loving to use Kaggle for these sorts of things, partially because I don't know if you can see over here, I got my iPad over here. 100% of today's stream was done on the iPad because I just did everything over on Kaggle. It's unfortunate. Like, I really love the iPad. It's like 90% of the way there to being a laptop replacement. But like right now I am using my laptop, and unfortunately that is because like streaming, like you can't do streaming well on an iPad. I didn't notice there's a question here. So the question is, how do you measure the accuracy of your outcomes while using RAG? There are many metrics that would help us verify the quality or output from the LLM. That is a great question, and a question that we'll cover in a future stream. I am going to dedicate a whole stream to that. And so the short answer right now is I will say look into the RAGAS framework, RAGAS framework. So that is going to be the framework that we're going to look at. We won't be touching on that today, but that is an excellent question because that, you always want to ensure that the quality of whatever you're doing is appropriate. So great question. Thank you for asking that. All right, so let's go ahead and do the pip install, perform pip install. Okay, so it's going to do my pip installs here. All right, this will take a little bit. Oh yeah, I guess I got to do, well, I guess I don't need to do that for now. So this will take a minute. I guess I should have done a little bit of pre-prep for this because these pip installs and stuff always take a little bit. So fortunately though, like you'll see very quickly as we get into this. Oh, is it already done? It might already be done. No, it's not. Don't lie to me. Anyway, the actual code that we're going to be enabling here today is rather simple and rather quick. Like it's rather easy. And I guess the one thing I should say as this is loading is we are going to be making heavy use of LangChain here. Now, I honestly don't know if we will end up leveraging Llama Index or not. Like, and it's not that I don't have anything against Llama Index per se. It's just I don't like the idea of commingling frameworks. So like, I don't know how well, basically what I'm trying to say is I don't know how well LangChain and Llama Index play well with one another. And I have a hunch that LangChain has been updated enough that it probably is now competitive directly to whatever Llama Index has to offer. I don't know. But just at least for today, we're only going to be making use of LangChain. I guess I'll go ahead and start typing in some imports and stuff while we're waiting. So we're going to need EOS, pandas. All right, what else do we need? All right, so from LangChain core import. I'm sorry. Core dot prompts import chat prompt template human message prompt template and then prompt template. All right. I think this is finally done now. All right, so I'm just gonna comment out this cell then. All right, so we need the prompts here. We need our runnable pass through, and I'll talk, well, don't worry too much right now, I'm just typing. I'll explain what each of these things are as we get to them. Runnable pass through. All right, from LangChain Chroma import Chroma. Oh, I think I'm gonna have to do an additional pip install for that. Chain community document loaders import data frame loader from LangChain OpenAI import chat OpenAI embeddings from LangChain text splitters import recursive character text splitter. And yeah, so I think I am going to need to do some additional pip installs though. All right, so the way that I did this, like, so this is like a helper function that I created to, because the nice thing about like what this does is, if you didn't catch the last stream, is it actually will save like our Python dependencies over here as part of the output file, and then you can actually do like a session thing where you actually persist the files, and so that way if you ever come back to your Kaggle notebook, instead of having to do all those pip installs again, it'll be saved there for you. Now you'll notice that I'm not saving it here because after the stream is done, I'm just going to blow away this notebook because I won't need it anymore. But yeah, so that is why I did this. So by default, if you were to look at this, it'll do like a couple pip installs. But if you wanted to make use of this and just do whatever sort of pip installs you wanted to do, all you got to do is pass in a list of what you want. So pip installs equals, all right, so I need LangChain Chroma, and I also need LangChain text splitters. And then I can uncomment this and then pass this in. So pip. Yeah, so you can even see there's the default pip installs right there. So I'm going to say pip installs. Wait, yeah, pip installs, pip installs. All right. So that's gonna, what this is doing is just downloading a couple of extra things that were not in my default thing there. Okay. Let me just, all right, so while that's loading, let me see, go ahead and start typing in some other things. So I need to load in my API keys. So I'm just, oh my gosh, I really should have done all the pip installs before I started up this stream. But we're like, this is the worst part. Like we're, after this is done, like after the pip installs are done here, then no more pip installs, I'm pretty sure. All right, we doing good? How are we doing? Are we still going? All right, and I'm going to comment this out because after this cell's done, then I won't need this anymore, and I just want to get this out. I need to figure out if there, well, never mind. I was going to say something aloud, but I just changed my mind as I was thinking about it. All right, is this done? All right, let me take a sip of my coffee. Okay. How are we doing? Yeah, I'm regretting not doing these pip installs beforehand. This is why, and this is why I created the script. You could see, because like this takes such an annoyingly long time that like doing the whole like output thing like over here and having it saved that way for like later times, then like that's such a nice little thing you can do. Okay. Oh, it's done. I wasn't even paying attention. Oops. All right, so all that stuff is loaded now. So I need to load in the API keys. API keys equals load API keys. All right, so that is loading my personal API keys in the background. And then finally, we need to load in our data set. So you can see here off on the right that we have referenced it from Kaggle. So if you want to make use of it, we're just going to copy the file path. And then I'm going to just call this df knowledge items equals pd pandas.read CSV, and then we're going to pass in our thing here. All right, so let's go ahead and look at what's in here just as a quick refresher. Okay, so just as a quick refresher, so we have 100 different rows here, and so we have 2 different columns. And I'm actually probably going to add a 3rd column here, but I won't talk about that in the stream. But yeah, so expect that to come. But basically, the first column here is the knowledge item topic. So you can see here that like this represents all the different topics for each of these individual knowledge items. So you can see here, this first one is setting up a mobile device for a company email. And then you could see that like the actual KI text here would be the actual text associated to the knowledge item itself. Okay, so the very first thing that we need to do is we need to load this into as like a document loader specifically that LangChain can make use of. Now this is going to look very different for different sorts of context. In our context here, we already have all of our items saved as a loaded pandas data frame. And so there actually is a pandas data frame loader in LangChain that we can use. In future streams, we will demonstrate how all these different items might be like different JSON files, for example, and we could still build a LangChain knowledge loader around that, or I'm sorry, a LangChain document loader for those specific contexts. So simply enough, though, if we want to use the LangChain version of the pandas data frame variant in LangChain, what we need to do is we need to create a document loader. So I'm going to call this KI doc loader. KI doc loader equals data frame loader. So this is the thing, one of the things I imported from above. And so we need to pass in a couple parameters. So the first parameter that we want to pass in is the data frame itself, df knowledge items. But you might be wondering, okay, how does it know which one of these is like which one of these columns actually contains the text? Well, simply enough, that is with this other parameter here. So page content column equals ki text. Now you might be wondering, well, what happens to this ki topic feature or anything else after we make use of this? And so let's go ahead and demonstrate what that does. So the first thing we need to do is that we actually need to formally load the documents up. So we're going to call this ki docs equals ki doc loader dot load. All right, so let's go ahead and look. This will take a second or two. Okay, so you can see here we got a bunch of different documents of this this document type. So let's just go ahead and grab out the first one so it's easier to read. So you can see we have this document type here, and so it's got the page content equals, and this is the actual content here. But the thing that I want to highlight here is that additionally, in addition to this page content, you have the metadata, and so the metadata here is actually referencing each of the different other features of this data frame. Now, naturally, the document loaders from LangChain are going to look different for like whatever context you're working in, if you're loading in JSON files versus loading in from pandas data frame. But you can see here in the pandas data frame context, it just simply takes in the other columns and sets them as metadata. So that's kind of nice that like it kind of does that automatically for you in this context. All right, so that is loading the documents. So let's go back to our picture just here and just kind of frame where we're at. All right, so we just completed step 1. Yay. All right, on to step 2. So we need to break into our document into chunks. All right, so in this particular context, we are just going to keep it very simple. In fact, we are just, so what we're going to do is we are just going to split on like number of characters. So the way that we do this here is we're going to use this thing called the recursive character text splitter. And you might be wondering what that means. I'll explain that here in a minute. So we're going to create a text splitter first. Text splitter equals recursive character text splitter. So we got to pass in a couple parameters. All right. Chunk size equals 1000. Chunk overlap equals 250. Length function equals len. And then is separator regex equals false. Okay, so let's talk about what is this thing doing here. So what this is going to do is it's going to take every single document here, and it's going to break it into chunk sizes of 1,000 different characters. And then you could see here, well, what is this chunk overlap parameter doing? And as you can imagine, like what this is doing is it's basically saying, okay, even though I'm getting all the chunks here in 1,000 increment bytes, I still want to have some overlap. And we'll talk more about that in future streams, why this is valued. But so let's just go ahead and run it so that way we can demonstrate what this is doing. Oh, I guess hold on, there is one other thing I wanted to talk about here. So I'm gonna copy and paste this piece of markdown here just because it's long, but it explains it well. I'm just pasting it from my other notebook. All right, so this is what I just pasted from my other notebook here. So why it's called a recursive text splitter is because you might be wondering, like, how does it actually know where to do like the split at? And so what it's going to basically be doing is when it gets around to this 1,000 character mark, it's going to go through and look for these different sort of delimiters. So by default, and you can specify these can be user specified. By default, when it gets to the 1,000 character mark, it's going to go down this hierarchy. So first things first, it's going to look for a double new line character. And so, all right, so if there's a double new line character, then we do the split there. If we don't see a double new line character, then we look for a single new line character, and then we do the split there. And then you can see that we keep going down. So if we don't see the new line character, then we just split on a space. And if there is no space in that neighborhood of the characters, then we just do a straight split. And so, and basically because the idea there is, like, ideally you don't want to be splitting like right in the middle of a word. Like, so you could see here, like the word receiving, like if I cut it off here, like that's not very helpful. So that's why they call this the recursive character text splitter. And so, and you can actually define your own, like how you want to do the splits. Now, again, in future streams, we will talk a lot more about splitting because, I would say this is a very naive version of splitting. And like I said, we're not trying to do optimizations in this stream today. We're just trying to build an intuition of how all this works in a very, very simple way. So we're just doing a very simple text split here. All right, so how do we actually do this or make use of this on our document? So just for context, the nomenclature is here that I like to use. I like to use the word chunks, but you will see them, so like these three pieces here that I call chunks, you will also see them referred to as splits. And so LangChain in particular, like all their document prefers to call them splits. So you'll see that I will also refer to them as splits every now and then. They're synonymous though, chunks and splits, and in terms of verbology. All right, so ki doc splits equals text splitter dot split documents, and then we're just going to pass in our ki docs from above. So same thing, passing this in here, and we're going to get our splits. All right, so I want to do ki doc splits 0 through 3. All right, so I just want to grab out the first three here just to show something. All right, so you can see here, now we have our different splits here from our first knowledge item. And you know it's the first knowledge item still because you'll notice that the metadata for all three of these documents is the same. It's all about doing the setup for the mobile device for the company email sort of thing. And that's why the metadata can be extremely helpful here. And this is why I actually kind of prefer retrieval augmented generation to fine tuning. And to be completely honest, I need to learn a little bit more about fine tuning to know what the true value is of one versus the other. But one of the real pieces of value that I think is really nice is that, like, so let's say your company is concerned that these models aren't perfect, and even with retrieval augmented generation, there could be some sort of hallucination, or maybe you want some extra context. So like when you are retrieving this sort of document context here, you could also have a metadata field in here that actually points to the URL of that source document. So like, let's say you build this automated system for your company that is doing like these automated answers based off of these questions. But if the user wants to learn more, then you can simply also retrieve out the source URL, and then that way they can just go directly to the source if the user wants to see that. Anyway, so yeah. Oh, anyway, so our 3 document splits here. So we did document splits of, what was it, 1,000 characters. So notice toward the end here that we have so we actually do have some double new line splits here that actually works out very nicely for us. All right, so you'll notice here toward the end of this first split that we have like step 2, set up email on document device. Now you'll notice if we come to the first part of the next split that we have the exact same text. And again, that is a direct implementation of the chunk overlap here. And again, we'll talk more about that in future streams, but basically, yeah, so we have all of our documents now split. So let's come back to our picture here. So we've split them. Step 2, done. Let's move on to step 3. So step 3 is just using the vector embedding algorithm and then storing them into the vector store. Now, the way this manifests in the form of code, it actually does a lot of abstraction going on here. So what I mean by abstraction is like when we actually run the code, it's hiding a lot of this away behind the scenes. So I have a love-hate relationship with abstraction in that regard, because I really like the simplicity of the idea, but when it comes to intuition and stuff, it's hard to learn just based off of the abstracted code. So in what I mean by that is, like, you'll notice here in the code that we're about to run that this code it like does not demonstrate this at all. And so, well, let's just show what I mean. So the first thing that we need to do is we need to instantiate our embedding algorithm. So I'm just going to call this embedding algo, and I'm going to simply be making use of the OpenAI's embeddings. And so I need to pass in, I'm going to pass in model equals text embedding 3 small, and I'm just going for small just because it's cheap and I'm cheap. And then I need to pass in my API key. API key equals API keys. And OpenAI API key. Okay. And so I've actually not tried this. I'm curious though. So let's see. Let's just see if I can generate an embedding for you really quick. Embedding algo dot invoke. Hello, everybody. My name is David. All right. So, okay. I've never actually done this before directly like this, so I'm not surprised that didn't work. It doesn't have an... All right. Well, it doesn't really matter. Like, basically, just know that this is the thing that the embedding algorithm that's going to be used. Okay, so what the vector store that we're going to be using in this stream, we are going to be using this thing called Chroma. So you may have seen me import this thing called Chroma. I would not actually recommend Chroma as a enterprise level vector store. The reason that we're making use of it here is because it's very lightweight and it can run in memory. And so that makes it nice for working in like something like a Kaggle environment like this. But yeah, like I would not actually recommend this for a real like enterprise context. And again, in future streams, we will cover different vector store options. At a minimum, I want to cover OpenSearch, AWS OpenSearch, and I also want to cover AWS, what do they call that? The Bedrock one, the Bedrock Knowledge Base, I'm sorry. And then maybe Weaviate as well as a third. But that'll be a future stream. Right now, we're just keeping things simple with Chroma. So I'm going to call this vector store. Vector store equals Chroma.from documents. All right, so then we need to pass in our documents. Documents equals ki doc splits. And then embedding equals embedding algo. Now, I'm going to go ahead and run this. It's going to take a second or so because basically, like, again, with the abstraction that's going on here, I guess that yeah, it didn't take that long. is it basically just did all of these 2 steps here with this code right here. And again, that's just not clear by the code, which is why I keep referencing back to this visual over here. So now that really brings this first part to a completion. We have our stuff in a vector store, so we are now ready. We are now ready for inference. So we're ready to move on to the retrieval augmented, or the retrieval generation side of things. All right. So, all right, what do we want to do here? So what we need to do first is we need to, in terms of LangChain, we need to get a document retriever. And so basically something that we can invoke and get like the documents back from our vector store that we just created. So the way that this works in LangChain simply is, so we have this vector store object right here. So I'm going to call this doc retriever. Doc retriever equals vector store dot as retriever. Simple enough. I spelled that wrong. As retriever. All right, there we go. So let's go ahead and just invoke this directly. So like, let's say retriever equals, or I'm sorry, dot invoke. So let's say I just want to ask a general question. How do I reset my password? So I think this is one of the documents in here. So you can see here that it is returned to us by default. How many? 1, 2, 3, 4 different documents. So basically by default, what it did was it found the 4 most similar documents and it ranked order. Is it 4? 1, 2, 3, 4. Okay. Yeah, it found the 4 most relevant ones, and it is giving back the context of how to do the reset of the password. And just glancing over these really quickly, it looks correct a little bit. Like I do see maybe a little bit of hallucination going on in here, but that is probably just because of the way that we did the chunking and stuff. Again, there are ways to optimize everything that we've already done. I keep having to reiterate that just to note, like, we will be covering those in future streams. Today's is really just basic to build the intuition for everything that we will be doing going forward. So this isn't perfect, but this is still, I mean, it's in the right direction though. Like, so yeah, so it's still trying to reset a password, but I guess I wasn't clear on what kind of password I wanted to reset. Yeah. All right. So I guess the next step here is really just then finally putting it all together. So we've demonstrated how we can. All right, so let's come back to here. So we just did all this really fast. We basically just did steps 5 and 6 with this retriever right here. Okay, so very simple. A lot of abstraction going on here. So now we're ready to go into steps 7 and 8. So where we actually combine the context of the documents with the prompt and then passing it into the model. So as you can imagine, we need to set up some prompt engineering to do this. All right, so let me make sure that my word wrap is on here. All right, so I'm gonna create some prompt engineering now. Prompt, I'm gonna call this prompt template. Prompt template equals, so actually this prompt template that I'm using is one, like, I guess LangChain has their own hub of templates that you can use. So I pulled this one from their hub. And you can actually do it programmatically too. It's just that I'm doing it by hand here just because it made it clear to me. All right, so you are an assistant for question answering tasks. Use the following. Hold on. I can't read my code down here because the word wrap's not on. All right, use the following. Uh-oh, my head's gonna get in the way. Let me move my head for you. There you go. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say you don't know. All right, so then we're gonna have the question, and we're gonna have the context. Okay, and there may be a better way to do prompt engineering for this too. And again, we might cover that in a future stream. Keeping things basic and simple for today. And we are actually almost done, which is actually going to time out well, because like I said, at 9 o'clock, mowing time. All right. All right. So prompt template. So let's go ahead and wrap this in the prompt template that we're going to be using. So I'm going to call this prompt equals chat prompt template. And I'm just doing, again, what LangChain did here by default. Like, I actually think this is a little bit, maybe much. You'll see what I mean here in a second. So we're going to pass in the context, the question. All right, and then, oops, I need a comma there. All right, so messages equals human message prompt template prompt. So do you see where I think it's getting a little bit much? I think there's a simpler way to do this. Like I said, I just pulled this directly from their hub thingy. So, I did this. This is the thing that I was talking about, like that I was doing right before the stream started, because I was too busy playing Elden Ring. Oh man, I'm never gonna beat that game. That is my favorite game that I'm never gonna beat. I think I put like 200 hours into that game, and the furthest I've got is into the fire giant that's on top of like that mountain thing. So like that's not even, I don't know if you'd call that even close to the end or not. Anyway, I was just making a little bit of small chat there while I was still working that out. All right, so that's the code there. Again, there's probably a better way to do that, but that's the chat prompt template. So then we also need to instantiate our chat model, so the actual LLM itself. So I'm going to call this just chat OpenAI. All right, so then API key equals, API keys, OpenAI API key. So that's my API key. And then, all right, so now we have all of our pieces. Now we can simply just use LangChain expression, the LangChain expression language, LCEL, to chain these things together. So let's call this the RAG chain. RAG chain. All right, so the first thing that we, so this is going to be a little bit new to folks. So the first thing that we need to do naturally is to get the context of the document from the question itself. So what we need to do here is we need to pass in this context, the context to the doc retriever. And then, so this is where like LangChain gets a little bit interesting, because you might be running, well, what happens to the question content, like the question itself? Like, how do I make sure that this still can like flow through to the next step, so we can make use of it in the next step? And simply enough, what we need to do here is we need to just take the question and then pass it through as this runnable pass-through thing here. So again, what this is doing here, actually, let me just go ahead and type out the rest of this code, and then I'll talk about what it's doing. Prompt. And then we have our chat model. Chat model again. Okay, so again, within the brackets here, step one, we are getting the context from the document retriever, but well, I guess this will make more sense. Like, so the rag chain equals, or dot invoke. How do I reset my password? Okay, so when we actually invoke this thing, it's going to go into this first step here. So it's going to, how did I know that was the question that I was wondering? I don't know. I'm a little bit confused now. Okay, so yeah, it's basically, oh yeah, okay. So it's passing in, like, this is like a parallel path here, if you will. So it's taking this as the context, and it's first passing into the retriever, and then it's also passing this thing here as like a runnable pass-through. So that way, when it gets to the prompt, then we'll have the context from the document retriever, and then the question just like filtered on through. And then like finally, after we merge that all together, we pass that whole prompt engineered template kind of thing into the large language model as represented here as part of step 8 to get our final intelligent response. So let's go ahead and invoke this thing. And then you can see here to reset your company's password, blah, blah, blah. So it's basically using the context of what was passed into it to be able to answer the question appropriately. Now, this is rather generic. I'm going to assume this is correct, though, based off of the context that we pass in. But yeah, that is the full RAG chain. That is an extremely basic RAG chain. Now, like I said, in future streams, we are going to be going throughout each one of these individual pieces and really carving out, understanding each of these pieces, how to optimize them. And as the person asked on YouTube in the question there, with the great question, how do we actually evaluate the accuracy of the outcomes and whatnot? We will definitely dedicate a whole stream to that as well. All right, so that really covers, do I want to cover anything else today? I think that's it. I mean, like I said, the code itself is rather simple. at least for a really simple link chain thing. So I'm going to go ahead and call it here. So that was good timing. All right. So like I said, this was the fundamental stream. We are constantly going to be referring back to the stream. In future streams, I will not be covering the core concepts again. So I will be pointing back to this video. So I probably should have done a better job about not looking so disheveled. But anyway, so I hope you all I hope you all enjoyed the stream. Hope it was helpful. And I will catch you. Looks like there's another question. How do we upload multiple documents and retrieve them? Well, we demonstrated that in the stream, and so I would recommend that you go back and review that here in the stream. So basically you can see here that all of these different rows represent a different document here, and then we used a special loader. I'm sorry, I'm not even sharing my screen. We use a special loader here. There are many different, so we just use the pandas data frame loader here. LangChain offers a whole bunch of different loaders, and we might demonstrate those in future streams. So like if you have all your documents in different JSON files or different Word documents or whatever, there are different loaders that you can use. It's just that we made use of the simple one here. So so yeah, that is that. All right. Any other questions before we get out of here? All right. Not saying anything, so we will go ahead and call it here, and I'm going to go and mow my lawn. Hope you all have a great day. See ya.